Hello, today our group will be presenting about solid state drive or SSD. So let's talk about what is SSD. An SSD or solid state drive is a modern storage device that uses NAND flash memory instead of spinning disk like traditional hard drive. Because it has no moving mechanical part, it can exit data almost instantly, which makes computers feel much faster and more responsive. This also makes SSD more reliable, more energy efficient, and significantly quicker in both reading and writing data. Next is SSD architecture. It has four main parts of SSD architecture. Let's move to the first one. It's a NAND flash memory. We store all the data. It organized into page and box. And because it can overwrite data directly, the SSD had to erase whole box before writing again. And the second is SSD controller, which acts as the brain. It manages where data is placed, handle garbage collection, while leveling and error collection. And the third one is DRAM or DRAM-less. Having DRAM helps the controller find the data quickly. So DRAM SSD give faster and more consistent performance. DRAM-less SSD are cheaper and may use the system RAM through HMB to improve speed. And the last one is host interface. This one is determine how the SSD communicate with the computer. SATA is slower, while NVMe over PCIe provide much higher bandwidth and lower latency, which is why modern SSD are extremely fast. Let's move on to the data management. SSD data management is essential because NAND flash can overwrite data directly. The FTL or flash translation layer can handle the mapping between logical and physical addresses and manage out-of-place light. And the garbage collection can clean invalid data to free space, while leveling space light evenly to prevent the early box failure. And the over-provisioning give the SSD extra hidden space to reduce write amplification, and ECC or error collection code collect the bit error. So all of these techniques can keep SSD fast, reliable, and long-lasting.
Let's look at how SSD work together with the operating system to improve speed, performance, and security. There are two main SSD interfaces. AHCI is the order made for HDDs, slower and higher latency. NVMe is a new run over PCIe, give very high speed and low latency. NVMe DOS send many commands in parallel, improving the performance. The trim commands allow the OS to tell SSD which blocks are no longer used. This helps the SSD clear unused data, reduce extra writing, and keep the device faster and healthy. Modern file systems like NTFS, APFS, and ext4 are optimized for SSD. The OS also use SSD-friendly scheduler such as Node and Deadline to lower latency and support the fast parallel I/O. This makes the system fast. To measure the SSD performance, we look at the sequential speed for the big file transfer, random IOPS for the many small file, latency for response speed, and the thermal throttling when the SSD slows down if it gets too hot. Moving on to the security. Modern SSD including hardware-based encryptions such as AES-256. These encryptions happen inside the SSD itself, so it does not slow down the computer. The SSD can protect data with a password or PIN. If someone removes the drive, the data stays unreadable. Many SSD are following security standards like TCG OVO 2.0. SSD also supporting the secure data erasure, trim clean unused block automatically during the garbage collections, and the secure erase permanent wipes all the data from the SSD. This makes the data delete safer and more reliable than the traditional hard drive.
Let's see case study and real-world application. Cloud platforms like Amazon Web Service and Netflix rely on NVMe SSD to handle millions of user requests. SSD remove I/O bottlenecks, reduce latency, and increase throughput by 5 to 10x compared to HDD. This allows their service to run faster, smoother, and at a massive scale. And let's see in industry of autonomous vehicle, self-driving car use automotive SSD to log huge amount of sensor data and support real-time AI decision, even under heat and vibration. And most importantly, in enterprise database, switching to SSD boost performance by 5 to 7x and reduce transaction latency from millisecond to microsecond. This case shows how SSD improve both real-time system and large-scale business workload.
In conclusion, SSD gives the higher speed, low latency, better durability, and strong security compared to the traditional HDDs. The operating system improving the SSD performance by using the NVMe, trims, optimized file system, and smart scheduler. Together with a strong hardware, encryptions, and secure erase, SSD have become the most reliable and secure storage technology nowadays computer. Thank you for listening.